Okay, hi you guys, I'm back. We are about to go into part 2 of graphing, and that is taking at sine graphs. I realized that in part 1 of the video, I had this here for the general form. It doesn't matter if this is sine or cosine. In here, it is, the graph acts the same way with these numbers around it. So let's go ahead and just do a quick review. Absolute value of A is the amplitude, so it tells you basically how tall the graph is. Absolute value of this B here, it's the number of cycles it makes. So depending on if I give you, radians or degrees, you use this for the period. Vertical shift up or down, that's what our C is out here. And then the phase shift is inside, right or left. So let's go ahead and get started with sine. The only difference with these, with sine graphing these, is that it doesn't start up top, whereas like cosine starts at a high point. It's important to remember that sine starts midpoint and goes up. So I'll do a quick recap about what all these numbers mean inside here. We have our -1, just means the graph is going to be shifting down 1. That's our sinusoidal axis. Our 3 means that's our A value, remember. The amplitude, it's going to be 3 above and below our sinusoidal axis. We have our 6 over here, so we're going to be starting with a shift left 6. That's our starting value. That matters for that one. And then our 12. This basically means that the graph is going to be moving 12 times faster than what a regular sine graph would have, if that makes sense. So our period should be a lot shorter than the regular 360, which we'll see here, once we start going. So I'm not going to write all of the stuff down like I did with the first cosine problem, just because it's a lot of writing. So the first thing is the sinusoidal axis, and we said that for that we look at this value all the way out where it shifted up or down. So it's going to be y equals -1. So let's come over here and let's have our -1. And let's go ahead and draw that in. I'm going to pick a color that'll stand out. And then I'm going to put my theta next to it. I have my y up here, so I'm in degrees. Okay, from here I need to pick my upper and lower bounds. So for that, you look at the A value, at the amplitude. And the 3 says that I'm going 3 above and 3 below this -1 here. So let's go ahead and go 3 above. So we have 1, 2, 3, which puts us at 2. Draw your dotted line. And let's go, I need to extend my axis here a little bit. Let's go down. 1, 2, 3, which puts us at -4. Draw your dotted line. So that's going to be with the upper and lower bounds. All right, so let's start graphing here. We need a starting point. In the starting point, you look at the phase shift, or this number inside. So it looks like the starting point is going to be 6 to the left of what it would be normally. So normally with a sine starts midpoint. Okay, so midpoint, I know it gets confusing. It's here. Well, with our new axis, it's down here. Oh my gosh, my daughter is playing with a xylophone. Savannah, okay, hold on. Okay, I'm back. So since the sine starts midpoint, it would be, down here with our new axis, and we're just shifting it 6 to the left. So don't overthink it. Here we go. We're at -6. That's our starting point, so go ahead and mark it. Remember, sine cuts right through. It's going to go up like this, okay? So now that we have our starting point, we need our ending point. And to find our ending point, we need the period. So remember, the period is 2 pi, or in this case, 360 degrees, over the absolute value of B, which in this case is 12. So we have a period of 30 degrees, which we said the period of this graph is going to be 12 times faster than a regular sine of x graph. So to know that the period is 30, to get from -6, you add 30 to that, so -6 degrees plus 30 degrees, you're going to end up at 24 degrees for an ending. So let's come over here. It doesn't have to be perfect, but try our best. -6 degrees, 24 degrees. All right, that's our ending spot. So you can go ahead and mark it right on the axis because that's going to start in the same, it's going to start and stop in the same spot on the sinusoidal axis. All right, so from here, it's the halfway time. So we know that a couple different things happen. We know that the sine graph, it goes up. Okay, it goes up, and then it's going to come back down before it hits that 24. So it's a little bit more difficult, I think, than the cosine. So the halfway point, so you could do, you know, what is obviously half in between our 24 and our -6. It's going to put us at 9 degrees. Okay. So we know something's going to happen there, and you might not be able to see it yet until you start drawing it. And then let's do our halfway point again, and I'm going to put here just halfway points, I guess. And then in between our -6 and 9, we're going to have 1.5. Put that there. And then halfway between 9 and 24, we're going to get 16.5. So now it's up to you to kind of determine and look, something's going to happen. So we know that our sine graph is coming up here. So clearly it's going to have a high point or a max point at 1.5. Then it's going to turn and come back down and cut through that sinusoidal axis at 9 degrees. And our low point, it looks like, is going to be at that 16.5. Work its way back up, and then obviously show that it keeps going. That's it. So sine's a little weird. I feel like you have to kind of wait until the end to see the magic unfold. All right, so that's the first one. The next one, don't pay any attention to that. Example 4. All right, so we're going to do this one in about, a minute or two. All right, first thing you look at, you see that our axis is going to be at y equals -5. We get it from right there. So here we go. -1, 2, 3, 4, 5. All right, new axis. Great. Draw it. Wonderful. All right, next point is to find the upper and lower. So upper and lower, you're going to look at the amplitude, which is 4. So you're going to go 4 above and 4 below. So we have, let's pick purple. Up 1, 2, 3, 4 brings us at -1. Draw in your dotted line. And then down 1, 2, 3, 4 puts us at -9. And draw in your lower bounds. All right, so the purple is the upper and lower. Okay, next step. We need a starting point once we're done drawing all of our axes and bounds. So our starting point, this is when you look, inside the parentheses, you see there's a shift. So it's a shift left pi over 2. So normally in a sine function, you're looking, you're starting here in the middle. I understand, we're shifting it down to accommodate for that. So you're going to go left pi over 2. So don't overthink it at all. Just go left, pick a distance, and put pi over 2. So now that we have a starting point, and we know with sine, it crosses the axis at the starting. Think about the origin, how it cuts through. Well, this is basically our new origin spot with the shift in there. So let's think about our period. So period is going to be 2 pi, since it's radians, over the absolute value of b, or 2 pi over, here we have 1/3. Obviously positive. Take that 3 back up here, and we're looking at 6 pi for a period. So, okay, if we already have negative pi over 2, so negative pi over 2 plus 6 pi, well, you can rewrite that as negative pi over 2 plus, with a common denominator, 12 pi over 2. We're looking at 11 pi over 2. That's our ending spot. So let's go ahead and mark it there. Great. All right, so we have a starting and ending. Now it's just time to find the middle points. So this, I know you guys sometimes with fractions, it's not your favorite thing. But if you know that the whole thing from negative pi over 2 to 11 pi over 2 is 6 pi, because that's what our period is here, half of 6 pi is 3 pi. So just subtract, or you could add, doesn't matter. I'm just going to do 11 pi over 2 minus 3 pi, which is the same as 11 pi over 2 minus 6 pi over 2, which puts us at 5 pi over 2. That's our middle spot right here. Okay, and you might be able to tell that, you know, it's going to cut through the sinusoidal axis here. If you don't see that yet, that's totally okay. All right, so then let's do our halves from here. So in between negative pi over 2 to 5 pi over 2, we said that that's going to be our 3 pi. Half of 3 pi is 1.5 pi, or 5 pi over 2. So we have, let's just go from 11 pi over 2. Let's subtract off that. Let's see, what do we have here? All right, our basically 1.5 pi, which is 3 pi over 2. We get 8 pi over 2, which is 4 pi. Okay, and when I originally did this, like in my head, I just did, okay, well, 5 over 2 is 2.5. 2.5 plus 1.5 is 4. So that's how I did it in my head. And then you add on, so this is negative 1/2, think about it. Negative 1/2 plus 1.5 is going to put you at pi. All right, so now it's time to figure out high, low. We know that sine, it starts, at midpoint, but it's going up. So we know that a critical point is going to be right there. It's going to come back down again, down, down, down. There we have another critical point on our lower bound there, and then back up. So if you want to sketch that out, here we go. There, 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 and that's it. So this last one was just more difficult because of, I feel like, the pies and figuring out it, everything in the middle. If you understand the concept, you'll be good to go for tomorrow, and also we'll get more practice with it tomorrow. So, all right, I'll see you guys then.